Hello everyone. In this video, I am going to derive the function of linear regression. So the goal is to find um, the best fit line to fit it in our data. So the function I will call it y prime equals m x plus b, okay, and the actual values are y's, okay. So I will define ri, which is the difference between the actual value minus the predicted value y prime, okay, and I will define the cost function j equals to sum of ri squared uh, I equals 1 to n, which is equal to uh, this summation I equals 1 to n yi minus mxi minus b, okay, squared. So I will try to minimize this this function to get the optimal values of m and b. So I will set the gradient of j to 0, partial j, partial m, because I want to get the optimal values for m and b, okay? And I will derive it partial j over partial m, partial bb, not m, to 0. Here I will get 2 times sum I equals 1 to n, okay, yi minus mxi minus b, by the chain rule I will multiply I will multiply by minus xi, okay, so the minus sign xi, okay, and I will derive it with respect to b. I will get minus 2 sum I equals 1 to n yi minus m xi minus b, okay. This minus sign came from here because d over dx of minus x is minus 1, okay. So I can find the value of b firstly, then I can find the value of m. Okay, I set this vector to 0, okay. So I will use the second equation, minus 2 sum I equals 1 to n yi minus sum I equals 1 to n. I can put the constant outside the summation, xi minus sum I equals 1 to n of b, okay, equals to 0. I can divide both sides by minus 2, so this minus 2, okay, so now I can simplify this equation by taking this term to the right hand side. I will get summation of yi minus m summation of xi equals to summation of b. I can write the b outside the summation and just putting 1 here, and the summation of 1 is nothing but n, because if I add 1 plus 1 plus 1 n times, I will get n. Okay, I can divide both sides by n, and I will get summation of xi over n, summation of yi over n, and this is nothing but the average value of y, so I can write b equals y bar minus m x bar. Okay, now I will try to find the value of m. Okay, first I can start with the first equation. I can discard the minus 2, okay, because the equation is equals to 0. So summation of I equals 1 to n yi minus summation I equals 1 to n mxi. I can put the x outside the summation, mxi minus b summation I equals 1 to n no summation of yi xi, because this xi minus m summation I equals 1 to n xi squared minus b sum I equals 1 to n xi equals to 0. Okay, I want to find these variables, so I can move this one to the right hand side. I get b sum I equals 1 to n xi plus m sum I equals 1 to n xi squared equals sum I equals 1 to n yi xi. Okay, this is the first equation. I will use the second equation also. So the second equation is sum of I equal 1 to n yi minus sum I equals 1 to n mxi minus sum I equals 1 to n of b equals to 0. So I can move these two terms to the right hand side. I will get this one is nb, okay, plus m sum I equals 1 to n xi equals to sum I equals 1 to n yi. Okay, this is equation number 2. Okay, this is equation number 2. I will use this formula as well as this equation, okay, to find the value of m. So I can write b, not b, I can write n, okay, n and sum of xi. I can write the second equation, sum of xi and sum of xi squared bm equals to sum of yi sum of yi xi. I will use Kramer's rule. So the determinant is n sum xi squared minus sum of xi squared, okay? I will find the determinant of m, which is n sum xi, and here I can put yi xi, okay? The determinant is n sum xi yi minus sum of xi sum of yi, okay? So m equals determinant m over the determinant equals to n sum xi yi minus sum xi sum yi over n sum xi squared minus sum xi all squared. I equals 1 to n, I equals 1 to n, I equals 1 to n, equals 1 to n, I equals 1 to n. So I got the value of m and the value of b, okay? And thank you.